Hey, Pretentious Engineer here. I know you didn't ask, but this is a beautiful example of how two objects tethered together can have this. So will we be able to accelerate past the speed of light? Let's go into that from an engineering perspective. So we have Harold and Gerald are tethered together. Harold's on the tractor. Gerald's going to be sitting on that little slide, and we're going to be rotating them around a fixed source. We have an R1 to Harold and an R2 from Harold to Gerald with some material that we're going to say is weightless. That's an assumption we're making. We're going to be leveraging the angular velocity to tangential velocity equations, and I'm going to be giving you some fixed distances that they're both going to go, as well as the speed of light in meters per second. So because Harold and Gerald have the same angular velocity, we can actually figure out what is the velocity that we should expect to see Gerald moving at with some of these initial R1 and R2 distances. So I'm just linking these equations together and then resolving it. And we can see that Gerald hypothetically should be able to go past the speed of light because that term for Vj is going to be much larger than c. All that said, is it actually feasible? Well, we can look at it from this perspective. Because of the centrifugal force experienced by Harold, you can also figure out what the centripetal force is going to be on that cable, which is tension T, which is bounded by the velocity squared, which is going to be the speed of light, by the way, and the distance from the rotational source. Here's a lovely stress-strain curve. Every material is bound by this in some regards. Depending on whether it's brittle or ductile, you'll see stress of F and stress of Y will be different values or the same value. And you can actually calculate your fracture stress based on the tension that's being experienced and the area. So I was able to calculate a rough area, cross-sectional area of this cable at an assumption of 1 meter of radius. And if you run all these numbers, go ahead and find a material property that has adequate stress to not break. And you could sip on that.